Hello, everyone. It's nice to have you here uh, in for today's lesson, which is Introduction to Natural Language Processing, and also we'll be seeing some common techniques in NLP. If we still have time, we can go to the third lesson, which talks about machine translation. If we don't have time, then we'll look at that tomorrow. So, if I may ask, can you hear me and can you see my screen before I continue?
You're loud and clear and visible.
Okay, so thank you. So, it's been a while since we met, but it's not, yeah, I know you've been going through the lessons, uh, both on data camp and also the presentations by Dr. Ibrahim and Dr. Shamsuddin. So today, what we will be covering here are some introduction, which I think is the title of the first lesson or the first presentation. We'll see some of the applications of NLP. We'll see some subfields in NLP because NLP is this kind of like a big umbrella that consists of several tasks or fields. So we'll be seeing some common techniques, and these common techniques includes basically some processing of the text that you'll do. And at the end of the day, you will see that NLP is basically just processing of text. And there's instances where some people see using multimedia or using speech is also NLP because you're all talking about natural languages and how do we communicate in natural languages. Sometimes we write them as text. So there's the argument that NLP is the textual processing or text processing, but there's also another argument that NLP includes images, includes text, because there are so much representation one can do using these various modalities in human language. So we'll be seeing some libraries in NLP, just saying some of them and explaining some of them. So also some challenges that are attributed to NLP, which you will see. And this area usually is most of concern for researchers in NLP, where you find what are the challenges and you try to give solutions. Some of the challenges have solutions. Some of the solutions are not optimal. So a lot of things you can do in the field of NLP. So as I said, if time permits us, we'll see some translation, what translation is in NLP. There is like several methods of doing translation, but it's one of like the very difficult aspect of natural language processing, doing summarization, doing summarization also. So especially if you have sequence to sequence processing, it's difficult. So, and you will see what we mean. And then we conclude by saying bye-bye. So our first lesson here is Introduction to NLP. What is natural language processing? So I think in the RWDS machine learning GitHub repo, there are some texts that explain some of these terms, and I think you have them arranged as ideal as possible, so you can follow there too. So what is NLP? So in this instance, when you are working in NLP, you will be hearing the word computational linguistics. There are normal humans that do linguistics. You will see a professor in linguistics, a person that did his degree in linguistics. What is linguistics? So linguistics is the idea or the study of human languages. You determine why things certain spoken in this way. How do humans communicate? What is the idea behind that form of communication and the rest? So when you use computer to try to resolve all of this mystery on human languages, you call it computational linguistics. So it's the story of using computer algorithms to understand and process human language. So it's all about a person being able to communicate effectively with another person. So you either talk or you write, or in the case of people that can't talk, you use sign language. So all of this uh, 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 are methods of effective communication. So if you use the computer to try to understand and process the human language, you are talking about computational linguistics. So in computational linguistics, there is natural language processing, because computational linguistics like encompasses a lot of things. So also, if you look at professional in linguistics, sometimes they will say, yeah, they go, they meet people, they record their speech, or they observe the environment in which people are interacting, are communicating, are telling stories and the rest. So a lot of things happens, not just the natural language. So natural language processing is one of the field in computational linguistics. There is natural language understanding, there is natural language generation, or some people call it natural language inference. So, and there is speech processing, there is video processing, video analysis, and a lot of it. There's the multimodal way in which you use text and speech, or use text and image, or use image and speech, or you use video, which is multimedia. So NLP in this regard is the field that focuses on enabling computers to understand and process human language. So if you look at the definition of computer linguistics and natural language processing, they are similar. But in most instances, when you hear natural language processing, it deals with textual analysis and the rest. So this is NLP, just using computers or algorithms or whatever to understand what human language is, to process it, to generate it, to classify it, and the rest. You will see a lot of applications in NLP, and you will see what is possible and what's not. And also in our everyday like interaction, we all deal with NLP in a form or the other. Sometimes you write some text on Facebook, and then maybe when others are reading it, it will give them this warning that there is either graphic content in this, or maybe there's hate speech in this, or there is abuse in this, or there is offensive language being disseminated in this. These are NLP. So these are algorithms that analyze your text and determine whether those texts have some sort of sentiment or some set of negativity, and try to warn other users when they are reading it. So also when you post the video and the video maybe contains something graphic, it might flag that too. There is some blood in here. Maybe some people do not want to see blood and whatever. So these are things. Also on your phone, if you are typing, it will be suggesting maybe the prediction of the next word, or it will be flagging errors in maybe your spelling and whatever. These are models, subtle models that does work on the background to try to help you in all of this. There is Siri on the iPhone. There is the speech that I think is a Google speech or whatever, that sometimes if you don't want to write, you dictate, it converts that to text, which is called speech to text. So there are a lot of things that are done here, and a lot of things that you've been interacting already with this. A lot of you have used ChatGPT to some sort in one way or the other to generate text, or to get the assignments done, or the rest. So these are natural language processing techniques and fields and subfields that in one way or the other, we've seen its impact, we've interacted with its application and the rest. So some of the history that listed on the GitHub include the Turing test. And what is the Turing test? During the development of AI, and I think from the initial stage up to maybe the boom that we are seeing today, up to ChatGPT, because I think most of us that are not deep into the area here are just familiar with ChatGPT. There are several models that does things that ChatGPT cannot do, but you all know ChatGPT. So from when Turing test is envisioned to this process, there are a lot of things that have been done. And what is the aim? The main aim there is to get computers to do things that only human beings can do. So you talk to a computer gives you response, and to some maybe laymen, they can't even understand whether it's another person that is in the background giving them the answer, because there are some people that if you type in ChatGPT and ChatGPT gives you answer or some other things, some persons will not even agree if you tell them, no, this is a computer. This is some sort of modeling that was done in the background to give you this response. Some people will not agree. So these are the things. The aim, and up till now, like we've not gone that much into it. There is a lot of innovation. There is a lot of progress that have been done. But even at ChatGPT, if you read ChatGPT's text, if you are very attentive, you will see that there are things that you may say, yeah, no, this is not a human that wrote it. Even though it's like it can be written in a way that is just very good, but if you look at it carefully, you will see that no, even let's say I give you now assignment and you submit ChatGPT to me, to some extent I can say, no, this is not how you speak. This is not how you write. This is not how any human being write, because there is a lot of perfection in it. And usually human beings make mistakes. So you need the computer to be able to perform in a way that you can't even determine whether is this a computer or is this a human being. So whenever a computer or a model or whatever tries or satisfy this, we can say, yeah, now we are in the position to see a computer now thinks like human, and we'll say this computer passes the Turing test. So Turing test is in the form of conversation with a computer, and the person conversing, the human conversing with a computer, will take a time talking to the computer in a technical sense, conversing with the computer, and then over several times, if you are not able to determine that you are talking to a computer, then you say, this computer has passed the Turing test. Then there is also the imitation game where it's explained that you have two people in another room, and then you pass letters around. You try to ask them questions while they try to deceive you, writing the response in a way that is deceiving you, so that you can't determine who is male writing this or who is the female writing this. So this is the imitation game. You are trying to determine the gender of two people, even though you are not seeing when they are writing, but you are asking them questions, trying to trick them while they are trying to deceive you. So, and the imitation game was implemented also in a computer. So these are also AI. The ELISA also is created to reconstruct human text. So if you say today I'm sad, it will extract sad word and say, why are you sad today? And you say it, you reuse sad and it reuse today. Such that I think this is just like basic, that when you give it something that is difficult, you said today today is Thursday, it might give you a response, why are you Thursday today? And so whatever. So, but these are things that try to imitate a therapist, and the earlier implementations, if you see this Turing test was done around 1950s, the imitation game 1939, this 1960. So AI have been around with us like for a long period of time, although now we are getting like the real capabilities of AI. And in the next 5 years, 10 years, you will see that whatever we know now are not that advanced, because every day people are working. Dr. Shamsu, as an example, is working on things that will try to revolutionize the African languages, Hausa, Igbo, Yoruba, and other African languages. So these are what researchers are doing, and this is also part of what Hausa NLP is doing. So trying to make sure that whatever we have now, we improve it in 5 years, 10 years time. And there are a lot of things that have been done already. So the applications of NLP. So NLP has several applications from healthcare and biomedical. I think all of you will know that there are several applications in NLP where people are trying to detect trying to detect. An example like Eliza as a therapist. So you talk to a computer and the computer analyze whatever you are telling it or you are typing to it or whatever, and trying to understand maybe your psychological situation or whatever, and trying to come up with things that will help you. Fraud detection, where you see text and maybe all this automated spamming of emails and text, where I think most of the Gmails, the email applications or servers try to automatically detect text where there is fraud. There is a lot of customer service where you have automated bots, you have sentiment analysis, you have machine translation, summarization, you have HCI, enhanced human-computer interaction. So there are different ways NLP affects the real world. And these are all some of the applications of NLP. Then there are things we call subfields, and each of this is a field on its own. So, and there are a lot of research in these different fields. These are not like this is not all of the subfields of NLP, but these are some of the subfields of NLP. You will see sentiment analysis, opinion mining, emotion detection, hate speech detection, customer intent detection and whatever, or consumer intent detection and whatever. So those things are also misinformation, classification of misinformation, detecting misinformation, detecting disinformation, detecting fake news. All of these are some of classification tasks that you will see within house NLP also, if you are that interested. And I think some of the attendees here also have one or two experience with some of the research we do in-house NLP. You will see a lot of sentiment analysis. You'll see name, also there is things called name entity recognition, where given a text, you are asked to determine what is the person in the text, what is the organization. If there is BUK, it should target here. There is something called BUK, and BUK is an organization. If there is a place, if there is a date entity and whatever. So these are applications. There is text classification, which generally might be like sentiment analysis or sentiment classification, emotion classification, topic classification, maybe news category classification and whatever. There is information extraction, where you are given a huge body of text and you are asked to just extract some information in it. There is question answering, there is machine translation, there is summarization, there is natural language generation or inference, there is the dialogue systems, there is speech recognition and synthesis. So there are a lot of subfields, and each of these are research areas on their own. So you can see, like, for each of these, if you take each one, you'll see there are thousands and thousands of papers that just try to solve one or two problems under this subfield. So there are several subfields of NLP. So, and this is it for the introduction to what is NLP, when NLP started, where we are now, with some of the things that are possible and not in NLP. But also, I think there is one exercise that was given in the GitHub. I think I've implemented it based on the solution that is provided in the repo. So we have this. Can you still see my screen, please?
Yeah, it's visible.
Okay. This is it. So the first is just generating a simple bot where you ask okay, where it's just random generation of responses. So it's just like you're talking to a computer at the back end, but not necessarily a computer. You can just trick it, given it the number or the valid responses you want it to generate. And what it does is just randomize the input. Sometimes the randomization can give you things that might be useless, but at least you are talking to a computer and it's giving you some form of response. So we have not gone to the modeling process where the model will understand what you are even asking before even giving you the answer. Here is just some random input output where whenever you write something, you just want it to just randomize from the database or from the list here or from the array here, whatever data structure you use, to just give you something that will imitate like it's talking to you. So this is just simple. So we just import random. This is a library in Python. The random, it will just randomize randomize the choices and then give you a just random choice. So we define our function, and then we just call the application, which is just a simple bot. And if you see running this, will just run this function for you, and it will print the introduction message. Hello, I'm Marvin, the simple robot. You can end this conversation by typing bye. After skipping each answer, press enter. So it will ask you, how are you today? Like the first prompt that it gives you. It expects that within this, what you have is you loop. This is what we call infinite loop. So it enters the infinite loop while true, because at each time the condition will be true. You give it while true. So while true, it continues this until you type the keyword by. It checks that if your input is by, then it just quit. And no matter what you give by, either all caps or maybe in sentence case or camel case or whatever you give it, it does lower. Maybe that means it changes the the what do you call this? It changes the casing. So, and it compares. If it is by, it just ended the program. So if you see here, is the input is waiting for your input. So I can say, I am fine, and then you press enter. So it tells you, let's change the subject. If you see the prompt is in here, let's change the subject. So it just gives you this prompt. So, and the next you will say, let's change the subject. You can just tell it, okay, and press enter. So it gives you, are you seeing this, or should I increase the size?
Yeah, it's okay like this.
Okay. So this is just a prompt. So I say, okay, it's a funny weather we've been having, isn't it? You can say yes, then press enter. That's quite interesting. Please tell me more. So you see, all of this prompts that are being, or the responses that are being generated, are just response that you give it from the choices. And these are the random choices that you give. You ask it to work with. And whenever you just type by, either by small letter, by capital letter, whatever, and you press enter, it will say nice talking to you, and the program will stop running because it has break from this infinite loop. And this is just simple bot. So, and to some person, if maybe we are not doing this lesson, and then I write just this simple program, and then I give you, you might be amazed. Yeah, so yeah, I'm working with something that makes sense, or something that is talking to me, even though, yeah, the token is this random. It might be that, yeah, there's a model in the back end that is giving you this random response. Maybe the model is not that very intelligent enough to give you something that is as relevant as possible. It might be. But then you might just give like some random responses that you ask it. Whenever I just give you the prompt, just tell me, just select randomly from this choices, and then give me the next. So this is just a simple bot, and this is just its implementation. So later in this presentation, we'll see some continue with this slideshow now. So are we following, please?
Yeah, very interesting, sir.
Okay, so
Yes,
in
sir.
the second lesson here, we are seeing some techniques in NLP. So we saw what is NLP. We saw some applications in NLP, some very, very, very minute history of NLP. There is like a lot of history in NLP. You can go and read that on your own. So, but there are techniques in NLP. So if we say NLP, we say there is translation, we say there is whatever in NLP, but how do you do it? Most of these tasks share something we call pre-processing or processing or extraction or whatever. So in machine translation, you might want to know in when translating, what is the name entity that do not need translation. So maybe if I say Idris Abdulmumin, I want the machine to understand that Idris Abdulmumin is a name and do not require translation. It will just be extracted from the text and reused in the final translation that you are generating without requiring it translating it, because it's a name. If I say Donald Trump, I just want Donald Trump to be there. And sometimes you might find the name of a person. If I may give an example, we have one footballer that his name was Drinkwater. So Drinkwater is drinking water, but the model should be able to know that Drinkwater is a name in that instance. Or maybe you say brown. Brown is, what color is brown in Hausa? So, but if brown is used in a sentence, the model should be able to know that brown there is used as a name and it should not be translated to be taken as a color. So these are some of the techniques. So also in sentiment analysis, sometimes we can say, yeah, there is something called aspect-based sentiment analysis, or what do you call this thing? So trying to determine in some sort of, if I'm saying Ibrahim is a good person while Idris is a bad person, if I ask what is the sentiment on Idris, it should be able to tell me, not taking the sentiment of the whole sentence, but extracting where is Idris and what is used to qualify Idris. So there is good, there is bad in that particular sentence. It should be able to know that bad is used for Idris and good is used for Ibrahim. So all of this form of like knowing what is the noun phrase, what is the verb, what is the adjective, and what part or what noun phrase or what noun is that verb or adjective or adverb or whatever qualifying or whatever. So these are some common techniques that if you go among most of the implementations of NLP, you will find them. So this is the essence of this presentation. So text pre-processing. So in most of the work what we do here, we first pre-process the text. If you give a machine a sentence, what it does is it takes it to its smaller units, which we often call them tokens. It splits them. Most of the basic form of tokenization that we know can be character level token, where angry can be split into ANGRY, or we can have angry people are not always nice. It will be split into angry as a word, people as a word, are as a word, not as a word, always as a word, and also wise as a word. So these are tokenization, because if you want to make sense, even for the human beings, if you want to make sense to most of what you are saying or what you are doing, what you do initially is to know the meaning of those particular individual words in either a sentence or document you are given, and then you put them together and you understand what they mean. So also that's how computers work. They get each word. Sometimes it's about knowing what is the importance of what in a particular sentence. So if I say angry people are not always nice, I want to know are not always wise. I want to know that, yeah, the people that are not always wise are angry people. So I have to be able to get these words interact with each other, usually at the token level. If you go deeper into natural language processing, you will see that there are different types of tokenization. Sometimes it's not the character level tokenization, which usually doesn't make much sense. At the word level, sorry, it makes more sense at the word level, but sometimes what's in a particular language, if you are dealing with, let's say, huge amount of data, can be a lot difficult to handle. So sometimes you go, you choose tokenization that is not at word level. There's some tokenization that we even call sub-word level. And yeah, sub-word tokenization, which you will learn if you go deep into natural language processing techniques. But there are also instances where you have millions of documents that even tokenization make more sense at sentence level, where you take particular sentences and you know what they mean, and then you put them together to form the document, and then you find out their meaning. Sometimes this works usually in tasks such as, let's say, summarization. So you have a whole book and you want to summarize it. What you really need is to go and find the important sentences that convey most of what the book is conveying, and then you build around those sentences, and then you come up with its summarization of that document. You try to put as much of the facts that are in the book in those sentences as possible. So there are various forms of tokenization that if you go deeper into this, you will see. But the first thing to do usually is tokenization. Then after you tokenize your text, you want to create embeddings. So embeddings usually are converting text from the textual format to number representation. And as you may have seen already in basic machine learning, but also in deep learning, but also in most processing, whatever you give a computer, it's first converted into numbers. Those numbers can be vectors, can be tensors, can be matrices, or whatever, but they must be numeric. And those numerical representation of whatever you are given, whether it's a text or whether it's a picture or whether it's sound, whether it's video, they are converted into numbers. And those numbers are computed in one way or the other to give you another representation. That representation, you convert it back into text so that it makes meaning, or you convert it into sound so that it makes another meaning, or you convert it into images or convert it into another video or the rest. So these are what we call embedding. So embedding are a way of converting text data numerically. So they are done in a way so that words, if we are working with words that have the same meaning or have similar meaning, usually you will find their cluster to be together. So if you have like I have respect, the highest snaps for you, they are my old friends, whatever. They are my old friends, I have respect, whatever. So if you plot this in a vector space, you will see what like is, are, and whatever appearing places appearing together. You will see makaranta, makarantu, makarantar, ɗalibi, ɗaliba, malami, like all of these words that usually you find them having similar meanings, you find them together. You will see daidai, ba daidai ba, or daidai mara kyau, kyakkyawa, and those things also that do have similar meanings. If you plot them in, if you get like very big text corpus and you convert this to embeddings and you plot them on a vector space, you will see all of these similar words appearing together. So these are embeddings. So after you tokenize the text, you convert it to numeric representation. And then there are things that I said you can do part of speech tagging, where you want to know what is the noun, what is the verb, how does the verb react to the noun, what it's the adjective, which adjective qualifies which noun. So these are things that you may do. So that's why I said they are part of the pre-processing or common tasks that are done in NLP for several NLP subfields. So you extract the words and their types in a sequence and recognize what words are related to each other in a sentence. So if they said here, Elizabeth was too much embarrassed to say a word, so you know that a word is what Elizabeth was trying to say, but she was too embarrassed. That means Elizabeth is embarrassed and she's not able to say that word. So, and to say is the verb, infinitive verb. There is too much is qualifying adverb, the adjective, sorry. The level of embarrassment is too much, and she was too much embarrassed, meaning whatever embarrassment it was done in the past. So all of these things, the model should be able to know them before even it understands and be able to process your text. Then there is what and phrase frequency as an n-gram. So you count the number of words in a sequence, you split the sequence into word of set length, so you can get unigram, bigram, trigram, or whatever number of words. So sometimes these are very useful in tasks such as during the era of machine learning to determine sentiment. There are words that do not make much meaning. So if you say Elizabeth was too much embarrassed to say a word, usually was too much to say a, most of them are things that do not make much sense. Whatever you what you need here is just Elizabeth embarrassed. So since Elizabeth is embarrassed, you know, if you are doing, let's say, things like sentiment classification, you might know that, yeah, this is somewhat negative, not like in a positive way. So you might say, yeah, there is Elizabeth, there is embarrassed. So this words that do not like contribute towards the meaning of sentences that much, we usually call them stop words or whatever. So in here, if you are doing word phrase or frequency or n-gram or removing stop words and whatever, so you can do this like this. Sometimes if you are doing evaluation of, let's say, I declare after all, there is no enjoyment like reading, how much sooner one tires of anything of a book. So let's say you give this in Hausa, and then the machine or the model or whatever NLP technique you did to generate translation gives you something similar to this. So if you want to do the evaluation, there is a way we do evaluation in machine translation where you generate all of these n-grams. And what is n-gram? N-gram is just the number of words. So if you are doing 1 gram, I is an entry, declare is an entry, after is an entry, all is an entry, there is an entry. So this is 1 gram. So if you are doing 2 gram, I declare is an entry, declare after is an entry, after all is an entry, all there is an entry, there is an entry, is no is an entry. So you see, you are taking these 2 words at a time, like 2 words at a time. You can do trigram, you can do 4 grams, you can do 5 grams, 6 grams, and whatever. So these are n-grams and phrase frequencies. So there is others which you can take, let's say, noun phrase extraction, where you want to know which is the subject or which is the object in a sentence. You can do sentiment analysis to determine, maybe before even doing some form of in-depth analysis, you can determine whether the mood there is negative or the mood there is positive or whatever. You can do inflection, where you take a word, particular word, and try to find it singular or plural. You can do lemmatization, where you find a word like, let's say, pre-processing, and you try to get what is the root word. So if you have, let's say, pre-processing, the root word is process. You've add pre in the beginning and you add ing at the end to give it another meaning, but the root word there is process. So sometimes you want to do this when doing pre-processing, because you don't want your vocabulary to be that very big, because sometimes if it is big, it requires a lot of processing or a lot of compute, like a very big computer to be able to handle that much amount of vocabulary. So sometimes for pre-processing, for processing, for processed, for pre-process, all of this, they hover around process. So you can discard every other thing and just hold process, because process like encompasses all of these different ways of putting process. You can have pre-processed, pre-processing, pre-processed, processed, processing, and the rest. So there is also WordNet. So WordNet is just like a database where words and their relationships usually are plot. So there too, like, helps, especially when you want to compare translation, or when you want to do next word generation, or like a lot of applications also of WordNet. So also there are NLP libraries. So libraries that you'll be working with. I think after this presentation, we'll go and see some of these libraries, text blob especially, and you'll see text blobs and its dependency on natural language toolkit, which is NLTK. So there is Spacey, there is Jensen, Scikit-learn, there is Stanford NLP. There is now the one that like almost everyone use, the transformers. They are libraries that like help you to do a lot of things. So these libraries usually just allow you or facilitate you to do a lot of things in NLP without you requiring to write them from the ground up. So you just take the library. If you're loading data set, you just load the data set. If you are loading the model, you load the model. If you are training the model, you train. If you are predicting, if you are generating, or if you are evaluating, you don't need to implement all of these codes. You just have to know how to call them, how to put them together to accomplish whatever task you are doing. Then the challenges in that in NLP. So we said we are talking about human language. And human language can be very, very, very difficult to understand. That's why you will see people that understand two or more languages usually are seen as like special people. You might say, yeah, I can speak Hausa, I can speak English, but then that's it. Sometimes you know Hausa, you know English, but if I ask you translate this sentence from Hausa to English, it will take you like, let's say 30 minutes just to translate one sentence. So it can be very difficult even for human beings. So talk less of machines, talk less of computers, talk less of automated ways of doing this processing of natural languages. So, and what are some of these challenges? We have things called ambiguity. Ambiguity is may have one sentence that can be understood by different people in different ways. You might say like, yeah, he is running into the court. Another person will understand that, yeah, he is running into, let's say, a court that is in Court Road or a legal court. Another person might understood, no, he is walking into that court. You know, there is something like lawn tennis. Tennis usually have their own court. Basketball have their own court. So a person might understand, no, you are talking about running into the court to play a game, or you are running into a court maybe to see the judge. So there is all of these ambiguities that might be very difficult for even a model to understand what you are talking about. Sometimes in ChatGPT, maybe if you write something, it will tell you, no, do you mean this or do you mean that? So that it's able to resolve that ambiguity and give you the response maybe that you'll be okay with. So ambiguity is a very big problem in NLP. There is context and co-reference. So context in a way where it might be during the early stages of doing translation. Sometimes if I start translating from the first word to the second, to the third, to the fourth, maybe I go to the 10th word, the model will have forgotten what it translated at the first instance. So the context of the last sentence might be totally different from what it's supposed to be. Because whatever you say, if maybe you are talking about something and you are given a very long sentence about that thing, if a person will cut the sentence in two and take the last part of it, another person that will read that last part of it without having the context of the beginning of that sentence will totally misunderstand whatever you are saying. So that's why sometimes you will see on the social media, they will give a short clip, a person saying something, and then it will garner a lot of uproar and whatever. And then the person will say, no, they took me out of context. Why don't you first listen to what I have said and then listen to what I said after this part of the clip? So in NLP, that also still is a problem. So there is out of vocabulary. We said usually there are as much vocabulary that you can use. I think by 2019, I think we developed the Hausa, the Hawi, which is called Hausa embedding. And in that Hausa embedding, we had words that are unique, which we may say we've not done lemmatization or whatever to get actually how many. But within that, if we say vocabulary, we mean the number of unique words, no repetition. We had about, I think, 98,000 words in that text that we built the embedding for. And I think the total amount of text that we used were just over, I think, 1 million tokens. So if you see there, you will see that there are 98,000 unique words, which forms your vocabulary. And in Hausa, that are not the only words. That is just the only words that are represented in that 1 million text. If let's say we have, let's say 100 million sentences that we are using, we might have like, let's say 250,000 unique words, which will all be in our vocabulary. And the model cannot handle all of them. So what it does, it takes the most important. So if let's say there is that appears, let's say 10,000 times, it will include is. If there is a that appear, let's say 5,000 times, it will include a, until it reaches the number of vocabulary that maybe it can only accommodate, let's say 50,000. And those 50,000 are the most common that appears in that particular text that you are using. So all of those, the other 40,000 will be discarded. So when you come to generate, the model will not know the other 40,000 that it's supposed to include in its own generation. That's why I said sometimes during tokenization, there are various ways that you may do tokenization so that you will include as much vocabulary as possible and I talked to you about subword tokenization, which is like a special formula that is used to merge all of these words together so that it reduces the number of vocabulary so that the model is able to get as much vocabulary as possible. So this out of vocabulary is still a problem in NLP. So lack of annotated data. We said there is machine translation, there is sentiment analysis, there is document summarization, there is a lot of implementations, but then in a lot of the times, you need data set that is annotated, especially by human beings, so that you give the model or you train the model with examples so that it is able to imitate human beings. Because at the end of the day, you want the model to do things just like humans will do it. So you have to train it. You have to give it a data. You have to say that if you see this is a school in English, in Hausa, it means wannan makaranta ce. So it will learn, yeah, if I see this, maybe wannan is this. If I see that, I know it is wancan. It tries to map all of this by embeddings, by several transformations, that whenever I see this word, I'm supposed to map it with the other word in the other vocabulary in Hausa. So, but if you don't have as much data of the examples you give the model, it will just learn from whatever you give it. If you give it something that is totally different, it might not have learned about that. It will give you something that is either generic or something that is wrong. So also there is this cultural and linguistic variation. You might say, yeah, in terms of linguistics, there is a way you put in something in English. This is a school. You see school as the object will appear at the end of the sentence. But wannan makaranta ce, makaranta here is not appearing at the end. So there is this linguistic variation where some words will be wanting to map in this way or the other, but maybe it's not supposed to appear in the same position as it is. So these are some of linguistics variation that might present some challenges when you are doing NLP. But a lot of this is solved by if you have sufficient and qualitative data set that has been annotated by human beings. So the last part of this is machine translation, which will not be seen today because we need to look at this also somewhat, not that in-depth because we are just talking about introduction to NLP. It's not in-depth. We are not going to see algorithms and how these algorithms are implemented, how they are advanced, how they are improved and whatever. So we are just discussing machine translation, what it is, how they are implemented, some of the algorithms that are being used and whatever. But we'll do this tomorrow because I don't think we still have enough time to cover this. So this is the end of the first and second lessons on introduction to NLP and also some common techniques that is done in NLP, including some of the challenges, some of the libraries, and also if we finish with translation, you will see some opportunities also that are presented. Either if you're doing some research or if you're doing some implementation, if you are just developing some applications and whatever. So quickly, what we'll do here is we'll go back to our notebook and see the lesson 2. You'll see, as I told you here, there is this thing called NLTK, Natural Language Toolkit. So it includes a lot of things. So if you run some codes, it will tell you that that code or that library is dependent on NLTK. So in NLTK, what you just do is you download the requirements, or sometimes if you just need the punct, I think there is punct here. There is a downloading package called Brown. There is punct. There is WordNet. There is Con 2000 is, I think, the Con library. There are movie reviews. So these are all data sets that allow you to do most of all these things. In the first instance, so here we just run this, and I think I've already downloaded it. So it will just tell you that, yeah, it's downloaded and it's up to date and it's finished. So what we did there, we said we did some simple bot where it just randomized and then give you whatever. So sometimes it will not make much sense, but if you use blob here, and blob here will be try to, let's say my name is Muhammad. We want it to extract the noun phrase in here. What is the noun phrase? And when you press enter, what it tells you here is that noun phrase. So we use Muhammad as small letter, so it was not even able to recognize. So let's try the same thing we can say my name is Muhammad in capital letter, and we see what this thing will give us. And you see now it's telling us that Muhammad is a noun phrase, meaning Muhammad is a noun in this text. So some of these things sometimes they are not that perfect, and this text block is just a basic library. You have like more advanced models that does that for you. So here is the implementation of advanced bot. At advanced bot here, you just imported the randomization, and then you extract the extractor, the call extractor. You give it the model here or the implementation here. What it does is it takes your sentiment. It determines whether there is some polarity, meaning anything less than minus 0.5 is bad. Anything less than 0 is less polarized than whatever. So it's not great, but it's not that bad. So anything that is less than minus 0.5 is bad, but anything that is less than 0 is not great. So everything that is less than 0.5 is positive, but if it is less than or equal to 1, meaning it's greater than 0.5, it is great. So you are trying to get like trying to implement something of a sentiment, trying to classify whether some person's emotion is positive or negative or whatever. So we can run this also. We've initialized the application. Say, how are you today? Or you can say, I am doing very well. So if you press this, it will tell you yeah, that sounds positive, meaning you are positive. Can you tell me more? I can say I am very distraught. I am very distraught, and then I said this. So this sounds bad. Because I am very distraught is just indicating that you are not having a good day. Maybe you are very angry or whatever. So you will say, oh dear, that sounds bad. Can you tell me more? So you see, it's trying to get your sentiment, and it's trying to give you some form of response. So if you type bye, maybe you finish chatting with it, you can say bye. It will tell you, no, yeah, now it's nice talking to you, just like it talks to you, but it doesn't know anything you said. It's just like, yeah, it's doing some form of computation and telling you that I talk to you. So if you agree that it talks to you, yeah. So this is the end of this demonstration also. I will wait here, stop here, sorry. And then, yeah. So I will stop here. I will ask if you do have a question, please, you should ask. Okay, Alila will kindly note that the NLP library, while installing it to your PC, Windows virus will pop up giving you this and that. Yeah, so yeah, Bala is asking whether the notebook will be made available. I think it's not that difficult. You can either implement it yourself, or I can share with you. Let me quickly share with you. I will give anyone with the link. Should I? Yeah, I think I will just give you viewer access. So what you do is, if you get the notebook, if you go to the link, before you are able to change anything, you have to save a copy of your own, and then you can run it. I put the link here in the chat, so that everyone in the meeting can see. I think, yeah. So yeah. So this is the link to the notebook. You can go there, open it, and see the codes, and you save your own copy, and then you practice. You can do a lot of editing or modification or whatever, because it's your own copy. But on my own copy, you cannot save whatever you edit. So you should save your own copy. And to save your own copy, what you do is you click here. You can see save a copy in Drive, or you can save a copy in your GitHub or GitGIS or whatever. But You can save a copy in your own drive so that whenever you open your Google Drive, if I may see here, my drive here, you can go to Colab Notebooks and you will see the notebook that you save, the copy of the notebook that you save in here. And then you can continue modifying it and using it and whatever. And you don't need to mount any drive. You can just use it. And to connect, usually you press here. Since I'm connected, let me disconnect and delete runtime. Yes, so you see there is reconnect here. Yours, when you open it in the first time, it will just show you connect, not reconnect. So it will be connect here. So do we have any question before we call the day and then meet tomorrow? The video will be shared after the meeting. We'll upload it to YouTube and then you will have the link, inshallah. So I'll assume that there is no question. So I will stop the recording now.